We are all good then? I think we can start.
Yes.
All right. That's awesome. So I think, okay. All right. So let's start then. Hi, good evening, everyone. Great to see you all. I'm so happy that we are resuming this cloud native group. Finally with new members. And now I feel like South Florida community is ready to you know um, contribute to the open source community and create a really strong local community. So I'm extremely excited. And then today we are going to have Case. He is a Kubernetes expert, and he's going to present, use admission controller of Kubernetes, using Fluent and flexible APIs. And then before we begin, if you haven't really registered yourself with the official CNCF channel, I'm going to post a link. So please join our community group. Okay, so you will be able to receive all the notifications for upcoming events. And if you want to participate as a presenter, or you have ideas, you'll be able to get involved. So please register with our South Florida local community group. Okay, so I think we can let's dive in. Case, you ready?
Yeah, can't wait. Let's do it.
All right.
All right. So I'm Case. I am a staff software engineer at Defense Unicorns. I see my colleague Kim on the presentation on the chat. And today we're going to talk about admission controllers, but very specifically, I'm going to talk to you all about something very interesting, and that's Pepper. And Pepper is an admission controller, but it's actually much more than just an admission controller. And I think you all are going to be extremely excited about what Pepper can do and what admission controllers can do for you all. Because really there is a very rich diversity of use cases that admission controllers can handle, right? There's like the why, which can be like security, like an OpenShift admission controller. You'll notice your pods running as run as user 65,000, making sure that everything admitted into the cluster is extremely safe. You have your Istio use case where it's actually injecting a sidecar envoy proxy in the pod beside your application container. You have like your Caverno policy type admission controller, your validating admission webhook. But anyway, let's just get into it. But again, it's a complete pleasure to be here. It's been a very rainy couple of days here in South Florida, but we're all here, so let's get into it. So we're going to start with the really introduction to Kubernetes admission webhooks with some super high level examples. Again, Kim helped me out with proofreading this presentation, so shout out to her. So what is an admission webhook, right? And this is a metaphor. Imagine there is this kids club where basically the kids go with their toys to enter in this club. Before they can get into the club, there's basically these two robots. The very first robot is called Mutate. And basically Mutate's job is to make the toys as cool as possible so that hopefully they can pass into the club. So Mutate is going to spray paint the toy if it's like an old car and it needs some paint, it's old rusted, or it's going to put a nice sticker on it, or it's going to change the outfit of the doll. It's going to change the toy, right? And then maybe there's another Mutate, and this Mutate changes the toy's shoes. And then eventually, after all the mutates, there's this validate. And the validate is the one that's you can enter or you can't. So the validate is doing things like, does the toy have sharp objects that could accidentally hurt people? Or does it have small things that the kids might swallow? So in this kind of very high level example, mutate and validate, these two are the admission controllers. It's the mutating and then the validating admission webhooks. So from a very, very high level, this is the children's toy club metaphor. Now I'm coming at you all from Miami, so I guess we have to have a club metaphor. Although I can say, honestly, I've never been to a club around here, but this might resonate with some people. So we're our Kubernetes cluster is a club. It's live. You know, everyone wants to go in. We've all seen these memes about people outside of that club at like 10 a.m. and like on a Monday. It's crazy, right? Everyone wants to get in, but there are two bouncers, right? And the first bouncer is Mutate. And what Mutate does is this club has a very strict dress code. So if the person is going in, they hit the Mutate bouncer, and the Mutate sees a hat on, the Mutate's just going to say, you know what, take off the hat. Actually, I'm going to take your hat off for you. So the Mutate strips the hat off of the club goer, and maybe they have I don't know, maybe they have a jacket that's too big that doesn't meet the club standards, so they have to take off the jacket too. And then eventually, let's say there's another Mutate too. The next Mutate gives the drink tickets for how much you can consume in the club, right? Because we don't want that one person going in and consuming all the club's resources. So then the next Mutate gives the drink tickets, the food tickets, and then eventually the club goer reaches the next bouncer, and that's the validate bouncer. And the validate bouncer checks and looks at the shoes, make sure there's no hat. And if the person meets all the criteria to enter the club, then they can go into the club. But if they don't, then they simply have to not get into the club. So these bouncers, these robots, these are the admission webhooks. There's simply two phases of admission control. There's the mutation phase, where literally the request, the Kubernetes object comes into the cluster, and we can see what it is. It's a pod, it's a service, or whatever it is. We can see its raw manifests, and then we can actually change its raw manifests. We can maybe assign resources like limits for CPU and memory, or we can assign limits for like the requests for CPU and memory. We can assign security contexts like run as user, like OpenShift does, but we can manipulate that pod in any way we want. We can even change the image if we want to a different image or location. And then finally, there's this validate admission webhook, which the mutate does its thing. It changes everything at once. And then the validate says, can this enter my cluster? Yes or no? And it's going to be an accept or deny. But that, in a nutshell, is admission control. So we're going to really go into this. Just make sure we all like really get this, because I want you all to understand like how awesome this project we're going to show you later, Pepper, is. So again, admission control phases, it can change things. It can remove the hats, and that's the first phase. And then the second phase is it can validate. Like after all these changes, is it really good enough? Like, is it safe? Is it going to have this noisy neighbor problem where this one pod consumes all the CPU, all the memory, drains cluster resources, and then the other applications start restarting, because now there's no more resources. So the Kubernetes definition is what I got off their site is the admission webhooks are of course invoked first, which makes perfect sense. You're going to basically change a resource, do all you want to your resource, and then eventually, secondly, and by the way, I want to say there can be a whole chain of mutations, right? I want to mutate this. I want to mutate this. Like I want to check security. I want to check pod resources. I want to check the image that it's not from some deny listed registry. I want to do another thing. And then finally, I have my validation phases. So I have one to look and make sure the registry is a trusted registry. Second, I want to make sure there's some assigned CPU memory resources there so that noisy neighbor problem doesn't occur. And then finally, I want to check and make sure the security is good. And then if all that's fine, then go ahead and go into the cluster. Now, so there is typically a lot of configuration associated with the webhooks, right? There's a mutating webhook configuration and there's a validating webhook configuration, and they have rules. And the rules, as you can see over here on the right, this lovely YAML is an array. And so you have your GVK, your group version kind, and basically you have your operations. So everything that happens in the admission is very much event driven. So when a pod is created, then I want to maybe I want to change the image location to an internal image registry, right? It came from a Google internal image registry, but now I want to deploy my own image registry internal to my cluster. I want to deploy the image there, right? And then I want to take it offline. So maybe I want to do something like that. An update, right? Let's say I have a pod that's updated. Well, I let the pod into my cluster and I checked its security constraints, its security context. It was running as a user like 65,000 or you know, it definitely wasn't running as root, because I certainly don't want anyone to escape out of a container of my pod and go into the node of my Kubernetes cluster and have exposure to my secrets, to all my Docker images, to essentially, you know, maybe even my AWS credentials. As soon as there's any update on a given resource, I want to know about it and I want to see the update, and I want to also decide if I'm going to accept or deny it, or if I want to change that resource. And then there are, of course, use cases that, like, you know, let's say I'm creating a Kubernetes operator, and an operator is like an abstraction for a very high level thing. But I have this operator, and I was talking to Kim about this today. It's called website, the website operator. And when I see a website operator, I'm going to deploy a deployment and a service account and a role. And this basically represents the deployment manifests for Kubernetes for my website. But once I see a delete operation on that operator, then I, of course, want to delete them. So I want to have it coming up. I want to have it coming down. I want to be able to respond to change. I want to control literally everything that goes on in my cluster. I want to have very fine-grained access. So the create, update, deletes, these are examples of operations here. And of course, resources, right? Resources are obviously like your Kubernetes manifests, your typical ones. Like you can have your pods, your deployments, your services, your config maps, service accounts, roles, rule bindings, namespaces, limit ranges, you know, all the basic stuff. But you can also have your, you know, your resources that are created in the cluster, like your Prometheus instances, your service monitors, your virtual services, your Istio gateways, your destination rules, authorization policies. It's anything that comes into your cluster, anything. So that's why this is so powerful, right? Like you can 100% control your cluster in any ways. So I want to, yeah.
Sorry to interrupt.
No
will you be able to make the screen, your presentation full screen, or you prefer the screen?
I don't prefer it, but my screen's really wide. Let me, you all tell me how this looks.
I think it'd be easier to see. It got small, no? I don't know. Is it big? Good. Yes.
Is it better?
No, I think it was better the other way. It's because
I get smaller.
Yeah.
Yeah. Actually, this is better. Yeah. All right. Sorry about that. Thank you.
No problem. Yeah, no problem. There's a way to make these slides full window, but I'm not sure how to. This might be better, right? Is this better?
Yeah, perfect. Thank you.
Perfect. Okay. All right. So now we're going to actually look at a diagram of admission control, and I'm going to show you all a snippet from Pepper, and this is actually from our repository. You can see it right here. This is this diagram. But so all we're really worried about right now is admission control, because we want to understand this. We want to put this into terms that we can easily understand. And so really what's happening, something comes into the cluster. This is an admission object. This is a config map. This is a service. This is a virtual service. This is an Istio gateway. And then there is an operation. That operation is creation. It's updates. It's deletion, right? And then after that, so basically a request comes in to the API server, right? The API server pushes it to the admission webhook, which can be a series of webhooks. We do all of our, first of all, our mutations on it. I want to set a label on this config map with name example2. So I set the specific label. After I'm done mutating the object, then mutates, pass it on to the validates. The validation, again, is a accept or a reject. So in terms of basic old Kubernetes admission, we're looking at a mutation phase and a validation phase. So this red-ish orange line and this yellow-orange line, right? So it's goes into the API server. We have created this mutating webhook configuration, this validating webhook configuration. It has the services that we deployed in the cluster, so the API server knows exactly where to send this request. In our Kubernetes service that's deployed, we're accepting this admission review object, which we accept, we manipulate, we change, we accept, we reject, and when we send it back, and it eventually is persisted to good old etcd. And notice there's this other thing, but we're not going to talk about that right now, but that's something Pepper gives you. That's something Pepper gives you. But let's make sure we understand this. So the admission of a pod. A pod's going to come in. I'm going to add a label. The first label is that this pod has been mutated. It's been seen by my admission controller. Secondly, there's this very famous noisy neighbor problem where any application developer, no matter how good, can have a memory leak, can have something they were not accounting for, and it can literally lead to consuming all the resources in the cluster. And what happens when you run out of CPU and memory in a cluster? Pods start restarting. So on that pod, we assign resource limits. Secondly, we assign security contexts to not only the pod, but the containers in the pod. And then finally, we validate that this pod is secure enough to enter the cluster. So this is just an example admission phase. So before we jump to Pepper, I want to make you all very comfortable with the admission controllers and talk about some admission controllers that you probably know or may not know. I mean, maybe we don't even identify them. Maybe we didn't realize like what this magic was that we were using, but like I think a lot of us have used Istio before. And Istio is famous for the good old Envoy proxy that Matt Klein created, those folks at Lyft. And what happens when you label a namespace with Istio-injection equals enabled? The pods that come up with a sidecar, and the sidecar is an Envoy proxy. So that is what mutation. So a mutation happens for every pod that's coming up into the cluster. OpenShift, I should have said this at first, but I used to work at Solo and I used to work at Red Hat. So I have a lot of long time experience with like OpenShift, GlueMesh, and Istio. But one funny thing about OpenShift is you deploy a simple Nginx pod like kubectl run, pod name, image equals Nginx, whatnot. And then you look at that pod and you see it's running as user like 65,000. How did that happen, right? Or why can I not run as root? Why do I need special permissions to run as root? Well, of course, that's the validating admission controller that's blocking you unless you've met said criteria. And then there is Zarf. There is Zarf. And Zarf is sweet. Zarf was created by the same guy, very brilliant, very creative, that actually created Pepper. His name is Jeff McCoy. And Zarf is an air gap tool. And the TLDR on Zarf is Zarf deploys an internal image registry in your cluster. And basically it pulls the images from AWS, from GCP, from Docker Hub, from Quay, from wherever, and it puts them in this, it actually stores them in this very small, very efficient ZST format, which was created by Facebook a few years ago. Many might not know that format, but it deploys them in an internal image registry, and then you can deploy every single thing cloud natively. So this can be deployed in submarines, disconnected, under the water, like a mile deep. It can be like, you can literally have any application deployed like this. You can deploy this in data centers. When you're setting up data centers, you're in an air-gapped environment. There's a lot of security risks. There are certain like banking applications, but the TLDR, their admission controller, basically they are, as soon as something comes through admission, they're saying like that GCHR or that docker.io, and they are changing that to the internal 127.0.0.1 image registry where the internal images are staying, and then the pods are mutated. This does not affect GitOps in any way because GitOps technically doesn't really look at pods. It usually is checking like deployments, stateful sets, daemon sets, and it works amazingly. And then Kyverno is a CNCF graduated project. It's a policy engine. It's super well respected. And if you know Kyverno or OPA, you basically create these policies and you say, I don't want any pod to enter my cluster that has an unsafe security context. So all these objects, I mean, obviously Kyverno uses it, but maybe we didn't know that how Istio did its magic, or OpenShift or Verzar, but yeah, these are super highly respected open source projects in our community. And so like really the why. So, today in 23 and in 24, it'll be the same. Certain people, or a lot of people, think that Kubernetes is complicated, it's convoluted, it's difficult. And this is like one of the things that I've heard a lot of people like really liking WebAssembly. They people think there's a better way. I've heard of like a Nix type replacements, but for now we're in Kubernetes, and there are ways to make Kubernetes like super simple, very simple. But first of all, let's talk about security posture. If you have like a managed Kubernetes platform, let's say, right, and you have app devs who are they know about Kubernetes, right, but they don't necessarily know about security contexts. Maybe they don't know about like syscall interface capabilities that you could potentially add on to pods that could, negatively affect your nodes on the cluster, create security compromises. You want to enhance your security posture. So basically, your devs can deploy their applications, and whatever they forget the resources, they forget the security context, it's going to add them. And by the way, I don't want to say devs because I made a really dumb mistake today, and everyone can make these mistakes, where I was basically doing a release of Pepper, and it was version 0.19.1, and I deployed version 20, not version 0.20, but version 20, like a major version, which was like, it just makes you think, like you'd never think you're going to make these problems, but human error is just a thing that happens. I was thinking about this demo, thinking about this presentation, and I mean, it's holidays. These things are going to happen, which brings me to my next thing. Anyone that's read the DevOps handbook, there's this guy in the DevOps handbook named Brett. And every time the application goes down, they call Brett because Brett has this legacy knowledge of the application, of the system. When this happens, when we get 100 users, the application will start creating these secrets, and the secrets will be half malformed. Well, guess what? If you have an admission controller and it's watching for secrets, and a secret comes in and it knows what the secret should look like, and then it checks the secret and it's not up to par how it should look like, then the admission controller can simply add more resources to the deployment, to add more resources to the application, so that things start the secrets are created in a better way. So we can actually program in legacy knowledge through the admission control phase, because we literally can see everything that comes in. It fixes the noisy neighbor problem. Again, a pod comes in, it doesn't have resources. Unfortunately, there's a memory leak that no one saw happening, but you know what? That doesn't have to happen. The pod, we can actually mitigate that by assigning limits and request limits on the pod's resources. Of course, our Kubernetes operator. When I see a Prometheus instance come in to my cluster, I know I need to create the Prometheus deployment, the Prometheus service. I need to make some config maps. I need to do et cetera, et cetera, et cetera. Everyone knows the operator pattern. And then there's literally too many more like strategies to name, but some of which are maybe doing multi-cluster. When something comes into my AWS US East 1 region cluster, I want to replicate that in my GCP Midwest region, just in case my AWS cluster goes down, because now I have redundancy. Or I want to create an audit of every single secret in my cluster, or of every single pod in my cluster. or I want to kind of push something to an external database every time I see this event happen. So there's many like strategies or why. But now the very most important part and the coolest part, the really reason why we're chatting here today, is we're going to talk about Pepper. And Pepper is an admission controller, but so much more. And it's extremely interesting. So we start out, and by the way, this is Pepper. This is the reason why Kim joined our team. She really likes the logo. I'm kidding. And this is Doug. Doug is a unicorn. We're the defense unicorns. But Doug's like question: don't you need a lot of config for an admission controller, right? Like if your controller is going to be mutating things, you probably are going to need a mutating webhook configuration. If it's also going to be validating things, you're going to need a validating webhook configuration. You're going to need a CA bundle, a TLS cert, a key, a deployment, a service, server's account, cluster role bindings. You know, you're going to need a lot of things. And I should say cluster role bindings with an asterisk. Through admission, you don't need permission to change things. But if you're going to do things after admission, like I see a secret, then I'm going to make an API call. I'm going to create a config map. As like an audit, you will need role bindings. But look to the right, like this is a ton of configuration. It's not for the faint of heart. Like you need to know what you're doing in Kubernetes in order to create an admission controller, like without a doubt. Like creating the application that is the controller that's going to accept the admission review object is one thing. But then configuring the whole thing is the second thing. Guess what? Pepper will do all of that YAML for you. All you got to do is write some TypeScript, write some rules. Okay, so check this out. This is a literal snippet from Pepper. When a config map is created with name example2, I'm going to mutate that config map by adding the label Pepper was here. I'm going to add an annotation, pepper.dev, annotations, I don't know what I wrote under that. Then after that phase, I'm going to validate it. I'm going to make sure it has the label. If it does have that label, I'm going to approve it, therefore letting this into the cluster. Here at the top, we can say I'm saying kubectl create config map example2 from literal, hi there. And I can see my config map was created. And then when I get that config map and look at the labels, you can see I never added any labels here, but the label was magically added. And obviously the config map is in the cluster. So Pepper is so much more than an admission controller, and it makes life simple for you. And right now, like very soon, ahorita, for you all who speak Spanish, we're going to actually dive into a demo. But it actually allows you to generate completely custom admission controllers from simple TypeScript code that uses a Fluent API that's super obvious. When whatever is created or updated, is deleted with name, with label, right? Then mutate, then validate. So that's what we mean by Fluent API. And it literally generates all of the Kubernetes configuration for you, and it is production ready. We're using this in prod right now. I didn't say this before, but defense unicorns solve some extremely, extremely hard configuration problems. And so that was why Jeff created this tool for these configuration problems. And he since handed it off to me. But these configuration problems are basically, you're going to deploy Istio, you're going to deploy Prometheus, you're going to deploy New Vector, you're going to deploy network policy. And by the way, your application developer has no idea how to configure any of this. We just want to deploy it and have everything automatically configured. And that's how we're using Pepper. But we're also creating operators out of Pepper. And then another really cool thing, really sweet thing about Pepper is it uses server-side apply. So when something comes in, we can simply here, like in a validate, in a mutate, we can literally like create another config map, create a secret, create a deployment. We can react to things, and we can even add more things. So the result here is it gives you complete control over anything and everything that happens in your cluster. And if you don't know about server-side apply, like this there was a lot of talks at KubeCon about server-side apply, but when you're creating an object, it simply sends the deltas for like an update to the Kube API server. And essentially that reduces the network pressure. So it's in a very efficient way to do things. And then there is the Kubernetes watch, which I'm sure we've all used watch here and there. But if you ever said like watch kubectl get pods or kubectl get pods / watch, you're actually streaming all of the events that come into that affect that given resource. So, something changes on the service, the ports change, an annotation change, a label changes. You're going to be the first to receive that event, and then you decide, do I want to react on that event? And that's even outside of the admission control phase. So that's for existing resources. So Pepper really gives you 100% control over what happens. All right, so Pepper in action. Yes. Perfect. OPA gatekeeper? That's OPA, right?
Yes.
Yeah. Okay. Really good question. Pepper and OPA are very similar. You're writing Rego in OPA. You're writing TypeScript with a Fluent API in Pepper. So for the validating mutating webhook, they're very, very, very similar. That's part of it. But Pepper has this other side of it where it's like it's calling the Kube API server, it's creating things, it's logging things. It's similar and also very different, but they could technically they could do the same job if that was what you wanted. You could write your policy engine in Pepper if that's what you wanted. Does that answer your question?
Yes. Thank you.
Okay. You're welcome. Great question. And that's a really very solid question. You can't use it in any other language, at least at this point. Initially it was written in Go, but the Fluent API wasn't really the same. So yeah, it's only in TypeScript right now.
Yeah. And then another question is, can we write an operator with Pepper?
Oh, absolutely. You can write amazing operators in Pepper. And if you all write some operators in Pepper, ping me. Find me on LinkedIn, Case Wylie. It's so fun to write operators in Pepper, especially if you've been using KubeBuilder or Operator SDK, but Pepper is perfect for operators. It's very good for it. Yeah.
Okay. Any other questions?
I'm gonna try it out.
Oh, do it.
I wrote some on KubeBuilder and the Operator SDK. It's nice now, but still not that fun.
Yeah, true. Yeah, I mean, when I was working at Red Hat, I was building a ton of operators, and you have to have a lot of intimate knowledge with Operator SDK, and with Pepper, you basically can react to admission events, which is technically all you need. So you have a reconcile loop in Operator SDK with Go. Anyway, it's different, but I definitely feel like, and my company feels like that we can build everything we need in Pepper. Although like we're a super huge Golang, we love Golang there, and we like Rust and stuff, but Pepper is just so simple to write operators in. It reduces the complexity. It's nice and fun. Yeah. So are there any more questions?
I don't see any more questions.
Okay.
Okay.
So the next slide is just like Pepper in action, right? We're doing that security thing. We're not emitting pods in because the hacker wants to essentially reverse out of a shell, out of a container that's running as root onto the node and perform, maybe steal our AWS creds or maybe do some blockchain mining operation. I don't know, but we're just saying, not on my watch. And he's like, IOTA man. All right, so let's call up the Kube API server. So how do you actually build a Pepper module? How do you get this started? Like, how do you go from TypeScript code to reacting when some kind of Kubernetes resource is created to all this Kubernetes artifacts, the Kubernetes manifests, the configuration that's created for you? That's actually very simple, to be honest. You say npx pepper init, and it's going to ask you some things, which we'll do together like very soon. And then you can say, oops, 1 second, that's wrong. Npx pepper deploy. Let me fix that. Npx pepper build. I'm sorry. Builds the manifest. Let's see that presenter view. That's what I need. Sorry. So npx pepper init is going to create a new folder for you with all the pepper manifests that you need, right? And it's going to give you a scaffolding. Then npx pepper build. Once you create this pod or whatever you're going to create, whatever events that you're going to react to, when you build it, that's going to extrapolate the Kubernetes manifests that are needed to deploy this into the cluster. And from there, there's this dist folder, and you basically do a kubectl create or a kubectl apply on that folder, and it deploys your webhook into the Pepper system namespace. So this is effectively how that works. And then in this example, we hadn't talked yet about how Pepper can just straight up talk to the Kube API server. But here we have this example where we have this Tecton pipeline. So when a pod, and it's basically like simulating a release, we're going to basically audit this release. But when a pod is created in the CI/CD namespace with name Tecton release, first of all, before this release is even persisted at CD, before it gets to go into the cluster, we're going to first get all the deployments, the current deployments in the staging namespace, so we know what the end result should look like. And then we're going to set a label and an annotation on this pod. And we're going to say, the very last staging environment had this many deployments, right? So that's our annotation. We'll use it later. Now, we will technically think about accepting this pod into the Kubernetes cluster if it has the current deployments, right? And if it has the annotation staging deployments. So then we're going to create this config map. And let's just say we have a front end somewhere, and the front end is basically doing like a kubectl get on this config map. So it's creating this nice little dashboard. So we create the basically backend for this front end with this config map, and we basically populate the raw data from this pod into the config map, like the candidate name, which we have assigned. We're going to get the staging deployments. We're going to get the current time when we started this. So we're going to basically, if it has these two labels, we're going to create this config map, and then we're going to approve the request. And then we're going to watch it for the remainder of its lifetime in Kubernetes. We're just going to keep watching that thing. So that's a pretty simple example. So someone had a really brilliant question about comparing it to OPA Gatekeeper. And we have one, and that's Kyverno policy. And this is we're going to compare that to a Pepper policy right now. But basically in our Pepper policy, and this is not the whole Kyverno policy, right? It doesn't fit. But you can consolidate all this YAML into a few lines of TypeScript. And what we want here is we want to make sure it's a huge security problem if your volumes are not read-only. If you can write directly onto the node, then you can basically like throw up a volume and then throw up a mount path and then like inject some kind of scripts in there. Maybe even like, there's a lot of bad things you can do if you can write to your nodes. So what this is doing is making sure your nodes, your volumes, paths are read-only. And this is the difference between YAML and TypeScript. Like it's so much easier in Pepper because you got this Fluent API. Not to say that this is not a great way too, but we think this is also a very nice way because basically you can just loop through all your containers on your pod and you can check if every single mount is read-only. And if they are read-only, then basically we're just going to reject that pod. And it's Fluent API. It's super readable. Like not all of us are YAML experts. So this will kind of work for your non-YAML experts, your cool app devs that are great in their subject domain. Anyway, that's me. And now we're going to actually get into the demo finally. So I'm going to have to stop sharing and then I'll start sharing immediately. Let's see. All right, so the first one is something I made for you all. I'm going to delete that. Didn't mean to bring that up. Didn't mean to make any changes. Don't save. All right, so I have this K3D cluster up, right? And if I could say,
Casey,
yes.
Would you mind put some couple of ticks to the font?
Sure, absolutely. Yep.
Perfect.
Sure.
Thank you.
No problem. No problem. So I have this brand new cluster up. We can see I don't have anything deployed. There's really nothing in here right now. But now I want to show you all this Pepper capability. And after this, I'll actually show you all how to create a Pepper capability. But first, I've created this capability. And what it does is effectively, it's first going to make sure this policy ensures that pods do not allow privilege escalation. Why? Because when pods become super privileged, they can do things like reverse shell out of their containers onto the nodes. They can gain root access. Like, we do not want to allow anything. I'm like OpenShift, right? I'm a Kubernetes development platform. I'm kind of extracting Kubernetes away a little bit. You know, my people that are creating these pods, they know what they're doing. But like myself today, we have human error, and like sometimes they're going to forget to actually create the correct security policies. So what I'm basically doing is, so if any, and this is a helper function. So Pepper is filled up with helper functions, kind of like an eBPF type thing. So it's like containers are basically going to get every container in a pod. So for each container in the pod, if the allow privilege escalation or privilege is equal to true, then I'm simply going to deny the whole pod. I'm just going to say, no, you can't do it, right? It's too much of a risk. My next validation is basically a mutation and a validation, but I want to require non-root users for all of my pods. And you know what? There are us or those Kubernetes experts out there that, you know, understand Kubernetes deeply. And so what I'm going to do here is let's walk through this, right? When a pod is created or updated, I'm going to loop through every single container in the pod. Now, as we know, not all pods and not all containers, not all containers have security context defined. So if the security context for the container, I say something like this, k run nginx image equals nginx, right? I don't have a security context defined. So I just created some nginx pod. If it's not defined, I'm going to go ahead and assign it a security context that I feel like is a sane default. So run as non-root true. Like, I do not want anyone to hack this pod. I'm going to go ahead and define something sane because I'm gatekeeping my own cluster. Secondly, what happens if we're running as user 0? Well, that user is excessively powerful. Like, they're a root user. You know, we know what happens when people are running as root. Likewise, when people are running as a root group, they have its excessive privileges. So I'm going to go ahead and make sure every single container in my pod does not have excessive security context. And I'm going to mutate that. But by the way, did you notice if my user is running as, if run as root is defined, right? If it is defined as like 65,000 or it's a something safe, I haven't changed that yet, because I don't want to necessarily change things for my platform engineers, my DevOps, my SRE people that know what they're doing, right? That this is not an oversight for sure. So we're going to look here. If it's undefined, if run as root is undefined, then I'm going to actually assign it like it's true, right? If run as user is undefined, then I'm going to assign a sane default. If run as root, if they forgot to define it, I'm going to assign something sane that I know is not going to get me into trouble, right? I don't want to get paged at 3 a.m. Hey, we're hacked, right? And then finally, I'm going to validate, right? So this is a pod, the request is a pod. I'm going to, make sure that the security contexts are not run as root. And so how do I know if the pod is root? The pod is root if run as non-root is equal to false. So if I'm saying run as non-root false, that means I'm technically running as root. If I'm running as user 0, that means I'm running as root. So this is just my little helper function to know, like, am I root? If my pod security context is root, I'm going to simply deny it. right? And that goes into it, right? Like maybe they assigned here their own, so maybe run is not, so let's say run as non-user was not undefined, but maybe it was like run as user 0, or sorry, run as user run as user 0. That would be a huge problem. So it was defined, but it was 0, so this didn't get hit. But you know what? I'm going to straight up reject that person from going to my cluster. That's excessive privilege. Something bad's going to happen. You're unauthorized. Your container security context, the containers must run as non-root. This is what you can do, right? These are some things you can do. Run as non-root equals false. Run as user greater than 1. Now I've secondly, because I really want to just really demo this more than anything, but I want to mutate something. So, not everyone assigns, like Kubernetes is scalable, and maybe you don't care about how much money you spend and you want to just like use an autoscaler and like scale up to like 10 gigs of memory. I don't know. But for each container, right? For each container in a pod, I want to also assign sane defaults. So if the resource limits are undefined, then I'm going to define some sane limits. If the requests are undefined, I'm going to define some sane limits. If the person defines these limits, then fine. I don't care, right? So let's get into a little demo then. So first of all, I'm going to say npx pepper build. And so what's happened right now? And let me do that again because I want to make sure you all see this. So there's this capabilities folder. This is where my TypeScript is, right? And I also have I have this like spec, this test. We'll get into that in a second. But yeah, I have this capabilities folder. This is my rules that I'm creating, but I'm creating them in TypeScript. And let's just go ahead and open this preview to the side so we all can see it. But the very first thing, I'm going to build this module. It's npx pepper build, I'm sorry. And we're going to see this dist folder happen. And now we have it. And let's look at this. So we have this YAML file, and there's all of the configuration needed. There's the cluster role bindings, secrets, deployments with our controller, service. We have our mutating webhook. We have our validating webhook. We have everything generated, right? And we can scope down our roles as much as we need. We actually have a way to say RBAC extremely scoped. So we can do literally anything we need here. So now let's actually deploy the module. But first, I'm going to create this test cluster. So I'm going to say K3D create cluster admission test. I'm going to actually show us all first my clusters. So I'm going to say K get context. So I got this default K3D cluster. I'm going to create this other cluster, this admission test cluster. And next, I'm going to open this to the side, so my spec to the side, and I'm going to look. I'm using Pepper's own Fluent client, like create this namespace. Then I'm going to create this pod. And it has this allow privilege escalation set to true. That should fail, right? Then I'm going to check for privilege. Privilege equals true. That should fail. I'm going to run as root. That should fail. So I'm just going to do these tests really quick and just make sure everything's working as I expect. So I'm going to say a kubectl create on the dist folder. We just saw that YAML output. I'm going to wait for the conditions ready for my pods. And then we'll go and run the test. Looking at the pods and Pepper system over here, you see it's not running yet. Still coming up. Cool. All right, so git code and Pepper system. Let's make sure everything's up. Cool. Our pods are officially now running. Okay. Now we are going to run the test. So we're going to create these bad pods, these super like high risk pods. We're going to just say run. And notice the second thing is like the secure namespace. So if we do kget namespace, we actually don't have this namespace. It's going to do literally everything for us. So it has created the namespace, and it's not allowing privilege escalation, and it is not allowing root users. So we know it's going to work, right? We definitely know it's going to work. But let's go back to my other cluster. Next, go back to my K3D cluster, my first one. All right. So this is my blank cluster. It's completely like free of anything. Now I'm going to actually deploy this thing right here, right? The thing I just created. And now I'm going to bring up some samples that I created as well. I'm going to say create force file in the dist. Get po in pepper system, and I'm going to show the labels. I'm going to just wait for condition ready pods label. Let's do this. Okay, conditions. All right, they got ready quick. So they're running. They're running. We can see they're up. They're happy. So let's go ahead and make this interesting. It's a live demo, right? So first of all, my capability is basically controlling, like a gatekeeper, my Pepper system namespace, right? So when I create a pod that is going to allow, that's going to be a privileged pod, and let's go ahead and create this namespace. Secure namespace. So we got secure namespace created. Let's create a pod, a privileged pod, right? And we can see its security context is privileged equals true, allow privileged escalation, true. Basically, this pod should be named Hackney, right? So, I can't create the pod in the secure namespace, right? Okay, get on secure namespace. I still have no pods there. What happened? What happened here? My Pepper webhook denied the requests. Privilege escalation is disallowed. Allow privilege escalation equals false. This is how we can get around it, but this is what it found, right? The security context privilege escalation is true. So that is a huge problem. I'm glad that didn't get in, right? Like that person could have maybe hacked me if they knew enough about what to do. So now let's look at something else, right? I'm going to look at this next thing. This is when a pod is created or updated, right? If their security context is undefined, right? If run as non-root is equal to undefined, like it is here, then we're going to actually assign it something. I'm going to say run as non-root should be true. If they forgot to create a run as non-user, I'm going to actually assign that for them. If they forgot to say a run as group, I will assign that for them. And that's just the pod security context, right? There's security context in the upper level of a pod and on each container. So I'm just going to say likewise, I want to assign sane security defaults. This pod has none. It doesn't mean it should be rejected, right? It's not necessarily dangerous. It just means that it does need these security defaults. So this pod should be, theoretically, it should be admitted into the cluster, but it should be mutated, right? It should be mutated here. And then after this, we have this validation phase where it checks, again, if the pod is running as root. In this case, it's definitely not running as root. It's got these sane defaults, it's fine, but it's definitely not running as root, because if it is running as root, it's going to get rejected. But in this case, there's nothing defined. So I'm going to create this pod. It's going to assign some sane defaults, and it should be accepted into the cluster. Okay, so I just created this pod. We can see it wasn't rejected, but now let's actually get this pod. So say get po in secure namespace with non-root pod, pipe route to YAML. And then specifically, what are we going to look for? Security context. There was none when I created it. So security context, run as group 1000, run as non-root true, run as user 1000, right? We have our security context. Oh my gosh, are there resources defined here? That's strange. I don't remember defining those, but there's also more security context. So this is a safe container, right? Like I want to basically control things, and I want to make sure everything that comes in is safe. But let's look at something though. What happened? Aha, we have another action here. When a pod is created or updated, if the container's resources, in this case, are not defined, I want to assign sane defaults. In this case, my limits, I don't know, like there's certain pods need more limits, especially if you're like crunching some numbers or doing some AI. But in this case, I'm running Nginx. So I think this is more than fine for a proxy. And here we can see like the defaults actually were assigned. But now I want to talk about overrides, right? Like, let's just say I do have this AI ML application, and I know exactly what my resource limitations will be. I certainly don't want my admission controller like messing that up, bringing myself down in prod. So here, this is, I know my application so well. It needs to run as user 65,000, just like an OpenShift, right? I need exactly 102 millicores of CPU. This is what my CPU and memory look like, right? I'm going to go ahead and I'm going to create this, and I do not expect it to be rejected or mutated because this is exactly what I need. Make my copy and paste work better today. Okay, so non-root pod 2 was created. Let's say KGO and what namespace? Secure. Piper out the YAML. So it's stuck with its own CPU, its own security context, right? So this does work. It's stuck with it. I'm not trying to mess up people. I just want to assign same defaults. Let's see. Anyway. So this is basically how it works. And now let's just go from scratch. Let's create our own, and we're just going to create a complete brand new project. Let's do this. It's going to be a 2-part thing. All right. So I'm going to say npx pepper init. I'm going to create a brand new module. Hello world. So here's my package.json. Create it. So as soon as it's created, a VS Code window is going to pop up, and then I'll share this new window. Perfect. Okay. So this is how simple this is, right? I'm going to go ahead and delete all my clusters. Deleting all my clusters. I want a fresh cluster for this. When I initialize a brand new admission controller in Pepper, I'm going to have this hello Pepper that's populated. So this is going to be, let me know if you all can't see. But this is hello Pepper. And basically, when a namespace is created, right, I'm going to remove the label remove me, right? Pepper in this capability is operating on namespaces Pepper Demo and Pepper Demo 2. I'm going to let it operate on all namespaces. When a namespace is created with name Pepper Demo 2, I'm going to actually create a config map. And this namespace Pepper Demo 2, I'm going to give it the namespace UID, and that's it, right? Then I have this notion of this Pepper store where we can store things across namespaces. So it's a way of using etcd, because a lot of times when you're crunching a lot of things that they come in, creating operators, you're wanting to store items. So we've abstracted this store from capabilities. So capabilities have stores, they have schedules like cron jobs. But I just want to get to the kind of TLDR here because this is kind of my wrap up right now as I walk you through this. When a config map is created, I want to validate that the config map has no evil annotations. If it does have an evil annotation, I'm going to simply reject it. If it's not evil, then I'll approve it. So anyway, I've deleted my cluster. Now I'm creating a new cluster. And now first thing I'm going to do is I will build this simple module. And then, this is the nice thing, right? Like we want to hold your hand when you're creating your stuff. So I can say like it's built in with so much IntelliSense, like when a dot namespace, when a dot, if I can write like network policy dot is created, updated, is deleted, right? Like all this is really built in for you. Like we have tried to make the developer experience incredible in this. So that's why there's like so much IntelliSense in this. But and we really think this can kind of like change the game of admission controllers. But let's go ahead and say npx pepper build. We're going to go ahead and build this module. There's no dist folder right now. We're about to have one. Okay, so now we have our dist folder. I'm going to say get namespace. We got, our basic default namespaces. Now we're going to go ahead and create the dist folder. So effectively now we just deployed our YAML file, which is effectively those manifests, the cluster role, the namespace, everything that's needed to deploy this. All right, let's go back now. Let's see this thing in action. Get pods in pepper system. We can see we have 3 pods running. And why? Because we have 2 deployments. We have, in pepper system, we have a watcher deployment, which is a single replica. And that's what we're going to watch existing Kubernetes artifacts that exist in the cluster. This, though, however, is our admission deployment. So let's make this a little more obvious. It's actually, something's in my way. Okay. Show labels. Oh, of course, pepper system. Now, we can see there is a pepper.dev controller. Make this a little bigger. There's a pepper.dev/controller watcher deployment, and there's a pepper.dev/controller admission deployment. And obviously, I can say, okay, get po in pepper system label pepper.dev/controller equals admission if I wanted my admission pods, or watcher. And then likewise, I can log, be very specific with my logs. Logs follow, and then like, I can spell though, right? Nope, still not right. How do you spell logs? Okay, there we go. Anyway, it makes it simple for the operator, right? That's our intention. So anyway, I see all my pods in Pepper system. They're running, they're happy, they're healthy. So let's see it in action. I am going to create a namespace, right? Name Pepper Demo with the label remove me. Uh-oh, that's a policy violation. I'm not going to reject it into my cluster. I don't care, like come in, but I'm gonna just remove that label. I feel like it's dangerous. So if I say K, create, force, into file, paste this, EOF, it's created, right? Of course it's created because there's no validate here. So if you say K get namespace, show labels, and we see this Pepper demo namespace, keep me, please. And then it has the basic default namespace, but we completely stripped that remove me label, didn't we? We mutated it off. Let's do another one. Let's create a namespace with name Pepper Demo 2, right? What's gonna happen? So as soon as I create this namespace Pepper Demo 2, I should watch it, then I should make this config map in Pepper Demo 2 with the UID of the namespace, okay? So let's say K create namespace Pepper Demo to. Perfect, right? Brand new namespace. Should I have this Pepper SSA demo? Probably. Pepper demo 2. Just get all the config maps in there. And wow, voila. ¿Qué tenemos aquí? Pepper SSA demo, pipe it up, YAML, namespace UID. We have it. So let's do a validation. Let's reject something. Let's get some of the validation. Let's get some with this example too, because I want to show you all something really cool before I wrap up. So I'm going to create a config map with name example 2. I'm going to merge some labels, and you notice we can do set label, remove label, set annotation. There's many ways we can do this. These are all helper functions. And then I'm going to validate that this Pepper label is here. It should be here, obviously, because I set it. But let's just create this config map. So create. Okay. Left. So we have this config map, right? And that should have went in. Perfect. There's a validate. Don't worry, it was accepted, right? Because it has the label request.approve. But I want to show you all this really nice thing we baked into the CLI, and it's going to be the very last thing. And let's check this out. So I want to know when a config map is created with this evil annotation, I want to reject it, right? So I'm just going to find evil here. So this should totally be rejected, right? Create and wait. Let's say npx pepper. Wait, first of all, get deploy in pepper system. And I can see this UID. And the reason I want this is because when I say npx pepper monitor help, it's going to say I need this module UID to monitor. And it's basically monitoring my validations. So let's do that again. npx pepper monitor, throw out the UID, and I can see everything that's come in so far. But now, let me create this config map that should be rejected, right? Because it's evil. Rejected. So no evil annotations are allowed. Anyway, folks, I really appreciate you all hanging out with me tonight. And I appreciate you all checking out Pepper and seeing, like, you don't have to have OpenShift to have this really powerful admission controller. You can actually have whatever you want, right? If you want OpenShift, you can have it. If you want to write these things very declaratively in TypeScript, that's very fluent. You can see what happens, and maybe react to change in a different way, right? Like maybe you want to create things on the fly. This is the way. This is a great way to do it. But folks, really appreciate it, and that's all from me.
His hand.
Sure.
Yes. I mean, this is awesome.
Nice.
I'm already excited. I'm gonna test it out for sure, and I'm gonna write some stuff, and I'm probably gonna be, enjoying it a lot. But I have I have a bazillion questions, but there's two that I might need your help here. So one is, so usually with all the other tools, Cube Builder, the operator SDK, one of the things is that is how can I control the same operator or the same admission controller permissions? Like I saw there that you generate the permissions, the RBAC for the same paper system and all that. So if I would have to modify that, and let's say that I write an admission controller, but I want to limit his capability, right? Also, because I saw that there was a lot of cluster roles and all that. So would that be possible? How?
100%. Yes. Yeah, absolutely. I'm so glad you asked that, because I didn't run it in scoped mode. So let me share, because the best way is to actually show you exactly how to do that. So check this out, Angel. You do not need permissions to run through to be an admission controller, right? You need permissions when you're going to do something extra. And basically, so let me delete this, right? And let me, before I even do that, I'm going to point to shout out our docs real quick. Let's go right here. And I'm going to come right to our docs. And very good eye, by the way. I'm going to say RBAC mode.
Okay.
So we can say when I run pepper build, right, the defaults, because we're still getting a lot of people on it, it's mainly used by our company right now, the default is admin, gives you cluster admin, right? But if I want to mutate a service or config map a deployment, I don't need any permissions at all for that. So I can run it in scoped mode. And you know what scope mode is going to do is the Kubernetes watch is actually an API call to the Kubernetes API. So let me, since we see this right now, I'm going to come back and I'm going to regenerate this exact same demo with scoped mode. Where are we? Screen night share. Oh, okay. Well, do we see something here?
Yeah.
Okay, cool. So deleting the capabilities. Let's say npx pepper build help because I don't remember. RBAC mode equals scoped. And this is a feature we just made pretty recently. So check this out. Here, okay. We don't want that stupid cluster admin role, right? Because we're being responsible. And this is all essentially about security. We don't want our service account with like this crazy permission.
Correct, yeah.
So go to dist, right? We're gonna look back and now we're gonna go our YAML file. Look at this cluster role. Now, does that look better?
Yeah, a lot.
That looks a lot better, right? And so this is just the Pepper store. So Pepper is very intuitive, right? When you're going to do a watch on an item, then that is technically, that's the Kube API server's watch. You're calling a watch on an item. That's how we can see things that are happening in the background or maybe before the admission controller was deployed. So that would be one reason. In this specific example, I didn't have a watch, but if I did have something, I would need the watch. Another thing is there's this Pepper store resource. So we look for kind, and that's how we do like the store.set item, or store.whatever, right? There's this custom resource definition that we use called a Pepper store. And that's why we have that cluster role on a Pepper store, because we're effectively writing to that store, updating the store, deleting the store. That's basically like how we're operating on the store.
Okay.
That's abstracted away. But that's why we need that one. But yes, you can 100% scope your roles by scoping down the RBAC mode. Now, I will tell you one thing, because I'm just going to be 100% transparent here. This, you don't need any resources. This would run just fine. But now, as you know, Kubernetes users that have a lot of experience in it, if I want to say like K8 dot like, you know, create an RBAC role or create a service, whatever I do in these validate or mutate callbacks, if I'm creating a resource against the Kube API server, then yeah, I got to account for that in my cluster role or my role. So the cluster role will scope it down to what you need for your watches, but then everything you do inside of there, you have to track that yourself. But there's like how we use it in prod is we scope down that RBAC.
Oh, I see. I see what you're saying. Got it.
Yeah.
Okay. So, I mean, I want to be mindful of your time, so I want to scope down my questions to like the most important one, and maybe we can get into a different session later. But the other one would be, and based on the intelligence that you showed me, like if I have, for example, if I want to use Pepper to watch CRDs from other products that I want to use, let's say cellular network policies, is that the data will work, or do I have to do something?
So that's a good question. I believe it would work once you register a type, and I'll show you what I mean. But I will say, let me validate that and come back to you. I think it will. So this is that Pepper demo when I said npx pepper inits, and I'm going to show you like a completely actually I can test this right now. So we create this kind, you know, we're the Defense Unicorns, that's our company, and we want to create this unicorn kind right here, right? And so let's just see if I can say when a unicorn is created. I'm not sure with that. So I can obviously say a generic kind, but when I say, oh yeah, it looks like I probably can.
So it's tapping into the cluster API. So whatever you can find on the CRD and the get CRD, you will also. Oh, okay, that's pretty cool, man.
Yeah, because Yeah, and it's really tailored for VS Code, and so like I didn't go into like debugging today, but I really should have. But like if I delete hold on, if I delete, I'll do this really quick and say, or maybe not, but I can say npx pepper dev and I can run in a JavaScript debug terminal. And what would happen effectively right here is I can actually put breakpoints inside of my cluster, so I can actually see the admission requests. So it's extremely powerful. Like maybe we'll have to do a round 2 of this, but the npx pepper dev is crazy powerful. Like we're always saying, like, we found things that are coming through admission that we never expected. Like you can just have such a clear view of the pods, how they get mutated, but you could like literally set a breakpoint right here, a breakpoint right here, a breakpoint right here. And it's really powerful. Yeah, and that's in Pepper dev mode when you have a JavaScript debug terminal. But you can totally do things like that. Yep.
Last one, I promise. I'm not gonna bother you. Sorry,
No
I saved all my question for last. Oh, the other one was more related to like and this is maybe because it's one of my struggles with the OpenSDK and the Kubernetes. It's like sometimes I just want to write a bunch of small things, not just one giant, like we know Istio, for example, which is a huge thing, and now they're breaking it down. So I noticed that everything gets deployed into the Pepper system. If I have multiple projects built with Pepper, would that be the same Pepper system, or how would that work in that case?
If you had, so Pepper by default runs in the Pepper system. But what you see here though are capabilities, and so it's made for scale. And so we have, so if we look at this, we have Hello World capability, and I should have shared the other one. But you can have a security capability, right? You can have a resource capability. You can have a capability that, a capability that I wrote is Prometheus capability. When I see a pod come through admission, or actually when I see a service come through admission, I actually want to create a service monitor to scrape based on that service's labels. So you can, so here, and basically in your pepper.ts, this is your capabilities. You could have as many capabilities as you want here. From capability, Istio capability, and that's exactly how we use it at Defense Unicorns. We use it like a lot for configuration and for locking things down, because we want our end users, like, their applications are so important, like, honestly, right? Like super secure, important applications. We want them to just deploy their application, and then we hook up Istio for them. Everything comes to the admission. We create the gateway. We create the virtual services. We create the destination rules. We create the network policy for them. We create the service monitors. We create the Prometheus rules, all from that one admission event. And yes, like, multiple different capabilities can also watch for pods. So that's how I think you could do it. In terms of if you can remove the Pepper system namespace, I don't think we can right now. I'm pretty sure that's baked in, but feel free to throw up a feature request, and we'll talk about it. Like, we're open for talking about it. And that's like github.com/defenseunicorns/pepper. Throw up an issue there. We'll chat about it out in the open.
Absolutely. Yeah. Like I say, it was more, it's not about removing, it's more about, like, if I'm thinking about an operator, if I want to write an operator, like something, usually you have your operator name system.
Yes.
So that was my thought process. But I'm fine.
Interesting.
Yeah.
That's an interesting concept. Yeah, I like that. I like that thought too. I think that's very, very valid. And yeah, that hadn't been brought up before, but maybe you do, when you're creating operators, you want to have your own very separate namespace. Yeah, like, let's talk about that. So that's a very good point. Very valid point.
I'm signing in for that feature for sure.
Cool.
Happy to help.
Awesome. Cool.
Thank you. Also great talking. Thank you so much.
Thank you. Thank you. Yeah.
I've been checking, and I think we already answered all of them. I saved mine for last, but that was awesome.
Cool. Thank you all. Thank you. Thank you. Yeah. Love it. Absolutely.
No worries. Baby presenting it usually gives some problems. Yeah. I want to mention something real quick, and I want to thank Case. He also joined us as an organizer here at the South Florida meetup, and we're really looking forward to do a lot of these events. And who knows, we might bring some KCD here to South Florida soon. So that's one of the goals. So thank you, Casey, for raising the hand and coming to help. And the other thing is, we feel that South Florida is another hub for Latin America. So you might see that we co-host a lot of the events with the Latin American community. Um, También hablamos español, así que cualquiera que tenga preguntas en español lo pueden hacer. Aquí estamos para colaborar entre las dos culturas, así que excelente. Los esperamos entonces para el próximo meetup. Right, he told me it's going to be when? January. Next year. Cool. Awesome.
Thanks, you all. Ciao, mi gente.